Alright guys, this video is going to be a refresher of using the quadratic formula. And yes, when you use the quadratic formula, this is something you have to know, you have to memorize. You did a lot in Algebra 2. And we use quadratic formula when a quadratic doesn't factor. Everything from the first day, everything factored. So to kind of refresh our memory here with quadratic formula, this is the form that it's in. Right, ax squared plus bx plus c. If this, I know a, b, and c are going to be numbers. If it doesn't factor, then to solve for x, then we use that. Here's the quadratic formula. The negative b plus or minus the square root of b squared minus 4ac over 2a. And actually, one thing I should have put here, in order to use this formula, it's got to be set equal to 0. If it's not set equal to 0, then you can't use quadratic formula. Alright, so if I looked at number 1, if what you would try doing first, if you were given this, you would try factoring this. Now, if you tried factoring this, nothing works. So the only way to solve for it is to use this quadratic formula. So I just note that this a is 11, this b is negative 12, and this c is negative 9. So I'm just going to write this. A is 11, b is negative 12, and c is negative 9. And I just take these and I plug them right into that quadratic formula. So if I have if I have negative b, when I take the negative of this, it becomes positive 12. So I'm going to have x equals positive 12 plus or minus. Then I have b squared. Well, if I square this, I get 144. And then I have minus 4ac, which is 4 times this 11, and times this c, which is negative 9. Especially on the inside of the square root, that's where you can really rely on your calculator. And then it's going to be over 2a, which is, 2 times 11? And then if we evaluate this entire thing, if we did 144 minus 4 times 11 times negative 9, if we let the calculator do the work, that gives us 540 on the inside. That's actually called the value of the discriminant. So we're going to have x equals 12 plus or minus the square root of 540, and it's over 22. And then the 540, I want to simplify that. I'm going to look for perfect squares that go into it. And I think the perfect square goes into it. 36 actually goes into this. And it goes into it 15 times. So I'll just make a side note there. 36 times 15 gives you that. So if you took the square root of each, it's going to give us 6 root 15. Alright, so we're going to have, let's see here, 12 plus or minus 6 root 15, and this is over 22. Now, the last thing we can do is just simplify. So, 12 over 22, let's see here, 12 over 22, that would just reduce to 6 over 11, and then 6 over 22 would reduce to 3 over 11. So this would just simplify to, I'm going to move in a little bit on number 2. This would just simplify to 6 plus or minus 3 root 15 over 11. So those are the two answers. 6 plus 3 root 15 over 11 and 6 minus 3 root 15 over 11. Alright, last one I'm going to do, I'm actually going to skip to number 4 for a couple of reasons. Let's move this. Let's go to number 4. Okay, we got a lot of space to work with here. Reason number 1, I can't use quadratic formula right away because it's not set equal to 0. So I want to move this 11 and this 4r over to the left side. Since they're both positive, we subtract. So I want to minus 11, subtract 11 from that 16, subtract 4r, and then subtract 4r from that 5r. And we're going to wind up getting 6r squared. So your 5r minus 4r is just plus r, and then 16 minus 11 is plus 5. Now it's set equal to 0. Okay, then again, this whole quadratic trinomial, if you tried factoring, nothing's going to work. So since it's impossible to factor the quadratic trinomial, go right to the quadratic formula. And when we do that, let's see here, a is the 6, b is 1 because it's just 1r, and c is 5. So I just plug this into the quadratic formula. Instead of using x, we're going to say r equals negative b. Since b is 1, we're going to have negative 1 plus or minus b squared, so 1 squared is 1, minus 4ac, so it's 4 times this 6, times c, which is this 5, that's all in the square root, and then it's over 2a, which is 2 times 6. Again, I'll use a different color here, if I evaluate this, that's the value of the discriminant. If you did 1 minus 4 times 6 times 5, that gives you negative 119. So we're left with negative 1 plus or minus the square root of negative 119 over 12. Now here's the other reason why I did this problem. If you have a negative in a square root, remember you can take the negative out and put an I for a complex number. And there's no perfect squares that go into 119, so we're just going to end up with, as an answer, negative 1 plus or minus I, right, times the square root of 119 over 12. So it turns out when you solve this one, these are two imaginary roots or imaginary solutions. Oops, trying to squeeze it in. So what that means is this graph never hits the x-intercept because the two roots or the two solutions are imaginary. So really, just to sum everything up, when you have a quadratic and it does not factor, you have to know the quadratic formula and you have to know how to use the quadratic formula to find the solutions.